Hey, you guys. I'm back and we're still on section 7.1, and this time I've got some fractions that we want to try to simplify. So the idea here is, again, they're using that really vague word, simplify, and what we want to do here is, because we see this square, it's going to be a good idea to factor that numerator and then see if we can cancel something out, like you would reduce a fraction. So if I concentrate on the numerator, I can factor that. Remember how we do that? We're trying to get sine squared. So we're going to put a sine x in these two slots. That gives the sine squared. And then we're trying to get the 1. So I want to put a plus 1 here and a plus 1 there. And that would, if you FOIL that out, that would give you that numerator. Okay, so we factored the numerator. And I'm going to copy my denominator back down again. And once we factor something, meaning we've multiplied it, we've written it as a multiplication problem, we can take out common factors. So you see that we have the sine x plus 1 in the numerator and denominator. And so I can cancel that factor out because that equals 1. And that then simplifies to this problem, or this expression, the sine x plus 1. So that's my answer. We want to try to just reduce those fractions. Okay, let me move to another example. Now, let me show you another example having to do with something different. So this next example, let me get back to my blue, has to do with radicals. So we're doing something called rationalizing here. For this example, let me write that down. So we're going to rationalize. Now we can do either the numerator or the denominator, and what that means is we're just going to try to get rid of the radical in the numerator or the denominator, depending on what they ask me to do. So let's suppose in this next example, we're trying to rationalize the numerator. Okay, so my example is the square root of sine x over cosine x. If I want to rationalize the numerator, I've got to get rid of the radical in the numerator. Okay, so if we have this one big radical like that, I can write it as separate radicals over the numerator and denominator separately. And so what I'm doing is I'm trying to get rid of the radical in the numerator because that's what they told me to do. So the way you can do that is to just multiply by another radical. So I'm just going to multiply by another sine x. And notice I got to multiply by the square root of sine x. Whatever I do to the numerator, I've got to do to the denominator. Okay. And what that's going to do is take me away from my, or get rid of my radical in the denominator. So I will just have the sine x in the denominator because a square root times itself eliminates that radical. And in the denominator, I'm going to have just one big square root and put the cosine x and the sine x together like that. So I know it looks weird, but all rationalizing does is it gets rid of the radical in the numerator and it leaves whatever we need to leave in the denominator. So that's one of them. Let me give you another rationalizing example. Okay, so let me do this one. So suppose we have the square root of sine x. Looks kind of similar, but it's got a power here. Cosine to the fifth of x, I meant x here. Okay, so let's suppose now I wanted to rationalize the denominator. Okay, so I gotta get rid of that. Okay, so that's a little bit harder because you've got your power here. So let me start like I did earlier. Let me start by making this separate radicals. So this is going to be the square root of sine x over the square root of cosine to the fifth of x. And there are different ways to do this, but I guess if you wanted to look at it in this way, we could try to make sure that power right there is an even power. And so I think I'm going to do it that way. So if I want to get an even power down in the denominator, that means I'm going to have to take my fraction. Let me write it back down again. And if I want that power right here to be an even number, I can multiply by another cosine, and that'll give me 6 cosines. Remember what you do in the numerator, or in the denominator, you have to do in the numerator. And what happens is that I will have, again, nothing special in the numerator, just sine x times cosine x. But in the denominator, I'm going to have 6 cosines. So I'm going to write this as cosine to the 6th of x. The reason that's nice is because what I can do is I can have, if I can take my power and my root, and remember, if this is a square root, that's understood to be a 2, and I can simplify the square root of cosine to the 6th simply by dividing 6 by 2. And that would make me have cosine cubed. So let me simplify that. Let me turn to another page then to show you that. Okay, so I'm going to have the square root of sine x over cosine cubed x. So square root of sine x cosine x. And remember, I had the cosine to the 6th of x, and it was the square root. And I'm telling you, I'll try to explain it better in a little bit. I'm telling you that that was simplified to this, so can't do anything to the numerator. This time we were trying to rationalize the denominator, but the trick here for this denominator is to take that 6 and divide it by whatever kind of root you've got, and that would be the new power. So 6 divided by 2 is 3, so the square root of cosine to the 6th is going to be cosine cubed x. And that would be a quick way to do that. So you're looking to get a number here that divides evenly with that number. Now, if you want to see that the long way, what I've got is I've got 6 cosines. So I've got cosine x, cosine x, cosine x, or you could think of it as, that's a lot of cosines, but I've got 6 of them. I'm not, see if I can fit them all in. And remember, every time you got 2 of them, you can take one out. So that's why you've got 3 cosines. But you know me and my tricks. The trick is just take that interior power and divide it by the root, and that'll tell you what your new power is. So let me try one more of those. Okay, so this problem is this one. So the square root of 1 plus sine y over the square root of 1 minus sine y. And let's say the directions this time are to rationalize the numerator. So that means I got to get rid of the radical in the numerator. All right, so again, separating that radical out. So see how all I'm doing is just writing separate roots there? Simplest thing to do is just multiply it. If it's a square root, just multiply by another one of those. So I'm just multiplying by the same thing that's in the numerator. Whatever you do, though, in the numerator, you have to do in the denominator. And what happens here is that you have the numerator simplifies to just 1 plus sine y, because you have the same thing times itself, and that eliminates the square root. But the denominator is different. Now, we want to remember how we did the simpler ones. We just multiply this times that. If you FOIL that out, you get 1 plus sine y minus sine y minus sine squared y. I'm trying to fit it all in, you guys. These cancel out. So what we end up having is 1 plus sine y in the numerator, and we have the square root of 1 minus sine squared y in the denominator. So 1 plus sine y in the numerator, nice, no more radical, and the square root of 1 minus sine squared y in the denominator. We're not quite done yet. We did get rid of the radical in the denominator, but what we have in the, we got rid of the radical in the numerator, but what we have in the denominator is an identity. And every time you see an identity, you're supposed to put what it equals to. So that's a Pythagorean identity. If you go look at the Pythagoreans, we said that 1 minus sine squared is equal to cosine squared. And then we can simplify this because the square root of a square eliminates the square root. So my final answer is 1 plus sine y over cosine y. And that's one way to do it when you have more than one term in the underneath the radical.